Hello, and welcome to the Ruby Robot Programming and Robotics Education channel. In this video, we'll be taking a close look at the VinciBot, a remarkable product designed to support both block-based and text-based coding. This robot helps kids learn coding from beginner to advanced levels, empowering them with hands-on experience in STEM. Developed by Matatalab, VinciBot represents one of the innovative STEM education solutions aimed at educational institutions and families around the world. Matatalab is renowned for creating interactive learning tools that cater to children ages 3 to 18, introducing them to programming, robotics, and artificial intelligence in an engaging way. The VinciBot itself is geared toward children ages 8 and up, making it an ideal STEM tool. I personally have a 10-year-old son in the 4th grade, and I'm eager for him to learn the basics of block-based coding and develop his algorithmic thinking before moving on to text-based programming. I believe this product will provide the right foundation and tools for learning, and I'm excited to share our experience with you. Now, let's get started with the unboxing. We'll examine the technical details and user guide, and later, we'll explore what kind of projects you can do with VinciBot. You can purchase this coding kit for around $100 from the official Matatalab website or from local retailers in your country. The box is designed with vibrant colors to capture children's attention, featuring the device's specifications on the sides and the box contents on the back. The VinciBot comes in a compact and well-designed box that not only keeps the robot safe, but also organizes all the accessories neatly. The box is packaged in transparent wrapping. As we remove the plastic covering from the box, we see that there's an additional security seal on the lid to ensure it hasn't been tampered with. The company places great emphasis on this. Inside, we find 2 booklets and a double-sided map. One booklet serves as a user guide, while the other includes 18 block-based example projects to get started right away. The box includes a double-sided map. On one side, there is a line tracing map, while the other side features square shapes with various color blocks and line patterns. This powerful little robot supports both graphical, block-based programming and Python. On the top of VinciBot, there are 3 programmable buttons alongside its patented LED RGB lighting structure, and on the front, it has a 16 by 8 LED matrix, which is surrounded by multiple sensors. These sensors open up a wide array of possibilities for creating interactive coding projects. On the bottom of VinciBot, there are wheels with high gripping capability on both the right and left sides, along with a speaker. Additionally, there are omnidirectional wheels at the front and rear. A 5-direction line following sensor and a color sensor are positioned at the front. These sensors can also detect gaps and cliffs. VinciBot is compatible with Lego construction pieces, technical motors, and other third-party electronic modules. There are slots for this on both sides, along with high-precision programmable transmission output shafts available on both sides. These shafts allow us to provide movement capability to our projects. On the back, there's an infrared communication sensor, while another IR sensor is on the front. A Bluetooth indicator is located in this area as well. Under the silicone cover here, there is a Type-C expansion slot where you can connect supported motor modules, light strips, and similar modules. This makes VinciBot's connection to the outside world more flexible. There is also a Type-C port for the data and power interface with a 5-volt, 2-amp capacity, compatible with most modern devices and offering a reversible, user-friendly connection. We see a lighted power button. The light on this power button also functions as a battery indicator. When the battery is fully charged, this LED glows white. When the battery is low, it turns red, and when the battery is at a medium level, it shines a yellow-green color. This way, we can easily monitor the battery level. Here's a protective tape on the black panel that covers the 16 by 8 LED matrix and its surrounding sensors. We can remove this tape. With Matatalab VinciBot, it is possible to make precise drawings. A washable pen is included in the box for drawing. These drawings can be programmed with VinciBot or created using the IR remote control. We will soon be doing sample drawings with this pen. The product also comes with a Type-C USB cable for data transfer and charging. A protective cover is provided to protect the sensors at the bottom of VinciBot and to enhance their sensitivity. We will mount this cover on the bottom of VinciBot. You can see the remote control specifically designed for VinciBot. This remote is of much higher quality and sensitivity compared to the IR remotes that come with Arduino sets. The controller is quite lightweight. There is a plastic film that blocks the connection between the battery compartment and the electronic circuit, just like in other remotes. To avoid damaging the battery compartment, we should not pull it out by holding the notch of the battery compartment. As you can see, it does not come out like other remotes. We have removed the film, but there's a screw here that we need to remove first to easily detach the battery compartment without causing any damage. We remove the screw holding the battery compartment with a screwdriver. After removing the battery compartment cover, you can see that the battery is included with the product. The battery is a CR2025 type. Since the product's target audience includes younger age groups, securing the battery compartment with a screw is a well thought out feature. In the next part of this video, we'll explore VinciBot's various operating modes, including line following and drawing modes. I will provide information on all the technical details of VinciBot. We mentioned that VinciBot is a STEM product. The goal of STEM education is to provide solutions to everyday life problems through an interdisciplinary perspective. It is based on 4 fundamental disciplines: science, technology, engineering, and mathematics, aiming to offer students high quality, critical, and constructive education by integrating these fields. Now, let's explore all of VinciBot's features in detail through practical applications. We are placing the cover of the 5-sensor unit, which performs line tracking and color reading tasks, on the bottom of VinciBot to protect it. This probably also regulates the sensor's sensitivity. To turn on VinciBot, we press the power button for 2 seconds. VinciBot turns on, followed by a blinking animation on the screen. If we want to turn it off again, we press the same button for another 2 seconds and VinciBot powers down. When we press the light button on the remote, we see the first animation effects of the RGB LEDs. Pressing the button again shows us 2 different RGB effects on VinciBot, and pressing it a 3rd time presents 3 RGB LED effects. These effects are preloaded into VinciBot. When we press again, the animation of the RGB LED stops. Now let's look at the sound and speed settings of VinciBot. By pressing the sound button, we receive audible notifications each time we press it, allowing us to adjust the sound level. This sound level adjusts the volume for VinciBot's dance mode and music mode. Similarly, pressing the speed button produces a sound related to speed. When we press it slowly, it indicates low speed, and when we press it quickly 3 times, we reach the higher speed mode for VinciBot. This allows us to adjust VinciBot's speed in both free mode and drawing mode, providing 3 different speed settings. VinciBot operates in 3 different modes. The M button on the remote allows us to switch between these modes. When we press this button, we see a fast animation indicating that we are in line following mode. The slow animation indicates that we are in drawing mode, and the plus and X symbols on the screen show that we have switched to command mode. After setting VinciBot to fast animation mode, we place it close to the line and press the play button, allowing VinciBot to follow the black line on the mat. Thus, in line following mode, VinciBot successfully completes its task without deviating from the black line. You can adjust VinciBot's speed while it is following the line using the speed button on the remote. However, if you set the speed too high, VinciBot may struggle to follow the line and make turns. Therefore, using it in slow mode provides a much improved experience in tracking lines. When VinciBot is in command mode, pressing the forward button will move it forward, and pressing the backward button will move it backward. We can also adjust VinciBot's right and left movements using the corresponding buttons on the remote, which works very accurately. When we press the dance button while VinciBot is in command mode, it performs predefined movements in time with the music. We can control VinciBot's dance moves through text-based or block-based coding. Similar to the dance mode, each time we press the music button, VinciBot plays a different piece of music with a different instrument. We can also customize these music operations using coding algorithms in text or block format. Let's continue our review with the drawing mode. We need to switch VinciBot to drawing mode. It is currently in fast animation mode. It draws in a slow animation. After setting it to slow animation mode, we can press one of the buttons from 1 to 3 on the bottom of the controller. Each of these 3 buttons contains a different predefined drawing mode. We'll try the first drawing mode. We place the VinciBot on the paper we will be drawing on. It will start drawing in the direction of the screen. Then we will place our pen on top of VinciBot, which we are doing now. After pressing the play button on the remote, VinciBot will execute the drawing in the first defined mode. Since this is a square drawing in mode 1, it performs the shape perfectly. Now we switch the VinciBot to the second drawing mode. Then, after placing the VinciBot on a white sheet of paper, we press the play button to watch what it draws in the second drawing mode. This type of application can be used to teach shapes as part of STEM education. In mode 2, the VinciBot successfully draws a star. Finally, let's examine the drawing of the VinciBot in mode 3. After switching the VinciBot to mode 3, we place it on the paper. Then, we press the play button to start the drawing. In this mode, the VinciBot draws an airplane, and upon examining the drawing, we can see that it completes it with 0 errors, down to the finest detail. This demonstrates how precisely the wheels and motors of the VinciBot operate. You can design these drawings using block-based and text-based programming instead of relying on preset modes, which is a key feature that makes this robot a preferred choice for teaching programming. This way, you can help your child understand geometric drawings and shapes by integrating technology into their STEM education. We mentioned that the VinciBot is compatible with Lego pieces. On the top of the VinciBot, there are also sections on the right and left sides that allow for the attachment of Lego pieces. As you know, children love to play with Lego. Therefore, the VinciBot's compatibility with Lego pieces will increase children's motivation to learn robotic coding using the VinciBot. Furthermore, the shafts on the right and left sides of the VinciBot will combine with the creativity of young minds using Lego pieces, enabling the creation of interesting interactive projects. See you in new educational videos about programming and robotic coding on the Ruby Robot Education platform.